I guess we only have these many students today. So let us start. Welcome to lecture 15 of our CS2 classes. And in the previous lecture, we started off with convolution, and we also had a look at, something about the compound distributions, which is denoted by S for our case. So we understood graphically what convolution means, and we had a look at, how to derive its formula as well. So for the PDF of S, which will be, derived through the convolution of the PDF of X and PDF of Y, we get this answer. And this is just F1, which is like X, and then this is the value that you assign, that you have to assign to the another random variable for it to sum up to Z. And then this is what you are varying because you assumed, and you started off with assuming one particular value for this guy. And again, the assumptions you have to remember, we did make certain assumptions. And then we also set to derive the capital F S. So, and at the end of it, we saw the derivation for the expectation, which was very intuitive because the expectation of S was just the expectation of the severity of claims times the expectation of the frequency of claims. And then we had a look at its derivation for the variance, which gave us something like this. After which we saw the NGF, and the very nice thing over here was the fact that we used that our x's are independent and that they're identically distributed as well. So maybe instead of writing identical, I should write identically distributed, right? So because they're identically distributed, that is why they all have the same NGF, and which is why this multiplication of mxi's n times, we can raise it just to the power of n to give us the answer at the end in a very concise, precise manner, which is this. So over here, this is a constant, and our ms of t is just mn of log of mxt. So today I thought, even before starting out with anything else, let me share with you guys something. So let us try to solve a question, I would say. So this is the question that I want you all to solve. Oops. Yeah. So I want you all to read this question and just tell me what does it say and how do you guys think you should approach to solving this particular.
And we can let x plus, n plus m equal to some other variable and proceed it with MGF.
Yeah, do you want to try to do that? So remember what they have asked you? They have said use a convolution approach to derive the probability function of n plus m. I mean, you could still use the NGF, no doubt about that. But what the question asks you to do is use a convolution approach. So this is the approach that we just studied, right? So this is like S equals to x plus y type question. So over here we have n following Poisson with parameter lambda, and we have m following Poisson with parameter mu, right? So you say that we should take n plus m equal to something. So let me just take it p. And this has Poisson with lambda and this has Poisson with mu. So, and again, we have this assumption that these guys are independent. So we have to use convolution approach to derive the probability function of n plus m, which is v here. So, which will be similar to, what we did for the s previously. So does anyone remember the formula that we derived at the end for convolution? You don't have to derive the formula again. You can directly use the formula and just substitute in these values. So I want you all to try that first. So let us try together. So what do you think I should start with? Let us say I define my n plus m to be equal to v. Then what should I be doing? Anyone?
From the formula that is on the same page, we can take that f of v is equal to integration f of m, fn of m into f of v minus m, fn of v minus m.
Okay. And so how many of you guys think what Vanshita just told me is correct?
Ma'am, it will be summation because it is discrete.
Right, so we are looking at Poisson distribution, so it is a discrete. So instead of integration,
Oh yeah, sorry.
we should be looking at a summation. All right. Anything else?
It will be
Anything else?
m. Ma'am.
Sum over m. So m will start from, what will be the limits for my m? So okay, we know that my n plus m is equals to small v. So now I have to define all the values that my small m can take. What do you guys think should it start and end at?
0 to v.
0 to v, and why do you think it should be 0 to v?
For the example that we saw yesterday, plus y equal to 10. So it can take 0, 1 to up to 10. Right.
Yeah, right. So x could go from 0 to 10. So again, why? Because in Poisson distribution, we know that the parameter has to be a positive number. So again, no, sorry, not the parameter, the number of events that will happen, right? It will always be positive number. So n is the number of claims and m is the number of claims, and so is v. So we know that all of these values have to be positive. So m can at max start at 0, and then the maximum value it will take is when n will take its minimum value, which is 0, and then m will be equated to v. So what I'll get is m starting from 0 and going on to v. Is this clear to everyone?
Yes, ma'am.
Right? Maybe I think yeah. So what should be my next step? Yeah. So what should be my next step? Anyone?
We know the PDF for Poisson distribution. So
Yeah. So what do you think I should substitute it? over there? So can someone dictate? What should I be writing next? Should I write the summation as it is? M will go from 0 till V. And for f of m, what will I write? E raised to minus.
Lambda raised to m upon m factorial.
So should it be lambda? Because lambda is the parameter for n.
It will be mu.
It will be mu, right?
Mu.
So we are talking
Yes,
about
it will be
this.
mu.
Okay. And then we'll have mu raised to small m upon m factorial. Does this make sense?
Yes.
So again, I would suggest do not look at the book and try to focus on what we are doing here. So what should I be writing next? What will come here?
E raised to minus lambda raised to n upon n factorial.
No, it's V minus n, right?
V minus n.
Exactly, right? So instead of n,
Yes, sorry.
I should be writing v minus m, right? So I'll have e raised to minus lambda raised to v minus m upon v minus n factorial. All right. So what can I do next?
We can combine it.
And how do you think I can combine it?
E raised to minus in bracket mu plus lambda. Yeah, just a minute. I think the rest would be as it is.
The rest would be as it is. So what do we have? We have summation m going from 0 till v, and we'll be left with mu raised to m, lambda raised to v minus m upon m factorial and v minus m factorial. Okay, so what can I do next? So remember, why are we doing this? We have to determine the probability function for our v, which is n plus m here. So what can I do next? Anyone?
And maybe you can take lambda raised to v outside, and then it will become mu upon lambda raised to m, like mu upon lambda the whole raised to m. But I'm thinking will it help us?
Let's try. So, okay, we only want, so, okay, remember what do we want at the end? We want, so again, we can maybe try that. So I have e raised to minus of mu plus lambda. And you say that I should take this mu raised to m and lambda raised to minus m common outside. Not exactly common, but because we have m going from 0 till v, you cannot necessarily take any of these outside, right? Because you're summing up across m.
Yeah, but v is not a random variable, right? So we can take lambda raised to v outside. No?
Oh, so you want to take lambda raised to v outside? All right. Yeah, we can do that. Yeah, lambda raised to v outside, and then I have summation. I'm going from 0 till v, mu raised to m, lambda raised to minus m upon m factorial and v minus m factorial. Okay, what can I do next?
So mu raised to m and lambda raised to minus m can be written as mu upon lambda the whole raised to m, right?
Yeah, okay. Anything else? So again, remember, whenever you really don't know how to solve this summation and everything, just head over to your table booklet and see if this looks alike any other distribution that you might have. So the very unique feature you see within the summation part is that you're summing across m, and in the denominator you have m factorial times some constant minus that itself, and then again factorial, right? So just have a look at all the distributions that are there in the table booklet and then see if there is any one of these which might match with what you have.
So again, it should be a discrete distribution, right?
Yeah, exactly right, because we have a summation. So it has to be a discrete distribution.
So in discrete, the factorial and denominator is in Poisson and negative binomial type.
Yeah, so do you guys want to try that? Are you guys trying?
I don't think it fits negative binomial.
And why do you think so?
I just compared the PDF and the numerator also has a factorial, and here we don't, so I don't think it does.
All right. What about others? Have you tried with negative binomial?
Yeah, even I had the same thought because it has a factorial with the random variable in the numerator. So
I couldn't hear anything that you said.
yeah, I also thought the same thing because it has the factorial with the random variable in the numerator.
Okay, all right. So what else do you guys think it can be?
Ma'am, if we modify and add v factorial, then we can get VCM and we can try with binomial.
Do you want to do that? Let us try. So what do you think I should be doing?
Multiply and divide by v factorial.
Okay, so I should be maybe, dividing it here, right?
Yes, ma'am.
And should I keep lambda raised to be outside?
Yes, for now.
All right. Then I have summation. I'm going from 0 till v, and I have to add a v factorial here. And I have mu raised to m, lambda raised to v minus m upon m factorial and v minus m factorial. Okay.
Yes, ma'am. So v factorial upon m factorial into v minus m will be VCM. And
Yes.
yes, ma'am. If we no, ma'am. No. Ma'am, here we can if like there is mu raised to m, and if we take the lambda raised to v inside, we'll have again mu raised to m and lambda raised to v minus m. So if we consider mu and lambda as parameters, then it can be binomial.
Yeah, so what should I be doing next? E raised to minus mu plus v upon v factorial, and I have summation. I'm going from 0 till v, vcm.
Mu raised to m and lambda raised to v minus m.
Right? And this looks a bit like the factorial that we have for the binomial distribution, right? Okay, so I would just maybe write here. All right. So what should I be doing next? I'll have this as it is, right? So I'll just write e raised to minus mu plus v upon v factorial. And how can I rewrite this thing as?
Mu plus
Like a
lambda
plus b
raised
the whole to n expansion.
Exactly right. So it would just be lambda plus mu raised to v. Instead of n, we have a v here, right? Okay, so this is what you get at the end. And can you further simplify this thing now?
Poisson.
All right. So you say that this looks like a PDF of Poisson with what parameters?
Mu plus lambda.
Mu plus lambda, right? So what did we start with? So we started off with n, which we knew followed Poisson with lambda as the parameter. And then we had n, which followed again the same distribution with the parameter mu. And we were supposed to figure out the distribution for n plus m, which we equated to v. And for the distribution of that v, which is defined as n plus m, we got that it again follows Poisson, but with the